Hello everyone. In this video, let's learn how we can use an 8-bit full adder as an adder and as a subtractor. So let's recap a little bit. So we previously saw that a full adder takes 3 bits, which are we can call AI, BI, CI for Cn, and it produces 2 outputs, which are the sum, let's call it S0, and the carry out, let's call it C0. So if we have two 8-bit numbers, let's call them the first number, let's consider it A, and we have it as A7, A6, A5, A4, A3, A2, A1, and A0. And each one of these is a bit. And another number, which is 8 bits, let's call it B, which has B7, B6, B5, B4, B3, B2, B1, and B0. And then on top here, we will have the carry out. So C0, which will always be 0. C1, C2, C3, C4, C5, C6, C7. So if we want to use full adder to add these two 8-bit binary numbers, we will need 8 full adders. And we can cascade them together. Let's call this one FA0, second one FA1, third FA2, fourth FA3, FA4, FA5, full adder 6, and the last one full adder 7. And then for the first full adder, we will have the 3 inputs, C0, B0, A0, which are these 3 bits here. C0 is always 0, and then it will produce a carry out, let's call it C0 and S0. And then the second full adder, FA1, it will take 3 inputs, the C1, which is the carry out from the previous full adder, B1, A1, which also will be these 3 bits. And then it will produce carry out, let's call it C1 and C2 actually, and S1. Then for the FA2, it will have also, it will take in 3 bits, 2, B2, A2, and then the C2 will come from here. It will produce a C3 and S3. So for the FA3, we will have 3 inputs, C3, B3, A3, and then it will produce a carry out C4 and S4. And this carry out from here become the carry in for FA3. For the FA4 full adder, we will have also 3 inputs. So the carry in C4, which will come from here, B4, A4, it will produce C5 and S5. So the inputs for the FA4 are A4, B4, C4, which are here. The next full adder, FA5, it will take 3 inputs, C5, which will come from here, B5, A5, then it will produce a C6, S6. And then the next full adder will take 3 inputs, C6, B6, A6, and then it will produce C7 and S7. And then the last full adder will take C7, B7, and A7. It will produce the last carry out and the last sum. And then again, every carry out from the previous full adder will become an input for the next full adder. So this is how we can use 8 bits full adder to add any two 8-bit binary number. But the question is, how can we use this whole full adder as an adder and as a subtractor? So let's see that, which is the purpose of this video. So before we do that, let's recap. If we have an XOR gate with two inputs, one of them is BI, and if we tie one of its inputs to 0, so what will be the output? Let's test it. If BI is 0, then the output will be 0, which is BI. If BI is 1, the output will be 1, which is also BI. So when we tie one of its inputs to 0, the output will always be equal to BI. If we have an XOR gate and we tie one of its inputs to 1, and let's call the other input BI, what will be the output F in this case? So if BI is 0, then F will be 1, which is BI not BI prime. If BI is 1, then F will be 0 in this case, which is also BI prime. Because BI is 1, F is 0, BI is 0, F is 1. So it's BI bar or prime. So how can we use this in our 8-bit full adder circuit? So let's see. So now we can use an XOR gate in these locations for the B bit. And let's see how we can do this. So instead of feeding B0 here, we'll feed it to an XOR gate. This is B0, and let's call this one, let's call it X0. And then for B1, also we can use an XOR gate, and this would be B1, and let's call this X0 as well. And then we can repeat this for all the B inputs. So let me do that really quick. So now we added all of these XOR gates, and then we fed two inputs, the bit, B bit, and then X0. So when setting X0 to 0, this whole circuit will behave like an adder. And then when we set X0 to 1, this whole circuit will behave as a subtractor. So this is how we can construct an 8-bit full adder circuit and then have it behave as an adder by setting X0 to 0, and then by having behave as a subtractor by setting X0 to 1. Hope this was helpful. Thanks for watching.